Now the next one, keys, the most important concept in the database engineering, that is key. This concept is also required when you prepare for the GATE exam. Most of the questions are there on the keys in the GATE exam paper. So keys, what is key? For that we are going to consider this instructor relation. The simple definition of key. What is key? For that purpose, unique identification purpose, we use the keys in database engineering. Also, or for the table, for the relation, we use the keys for unique identification. So key is a set of attributes that sufficient to distinguish entities from each other. So this is the instructor entity set. In that instructor entity set, there are 12 entities. This is the first entity, second entity, third entity, fourth entity. In this way, 12 entities are there. So how to distinguish this entity from this entity? First entity from second, second from third. For that, a key is used. What is this key? A key is a set of attributes that sufficient to distinguish entities from each other. How to distinguish it? That is the simple definition of the key. Now super key. A super key of an entity set is set of one or more attributes. See, key is not a single attribute. It is a set of one or more attributes. Minimum one, maximum any number of attributes you can consider as a key. So a super key is an entity set is a set of one or more attributes whose values uniquely identify each entity. Whose values uniquely identify each entity. Means if we consider here the super key as ID and name, instructor ID and instructor name. So each this super key or this set of attributes, these two attributes together identify each and every entity. Means 2, 2, 2 Einstein. This is the first entity. 1, 2, 1, 2, 1 U. It is the second entity. 3, 2, 3, 4, 3 EI Ilsid. It is the third entity. In this way, this ID and name together we can form as a super key of the instructor entity set to identify or uniquely identify each entity. Now see, this super key may contain some extraneous attribute. Again, this word is important. In normalization, again we are going to see this. So a super key may contain extraneous attributes. The extraneous means the attributes, if we can remove it, if we can remove that attributes, then it also identify every entity uniquely. For example, suppose here in this case, I remove this name attribute. If I remove this name attribute, this ID also uniquely identify each entity. Why? Because it is unique. Why? Because each value of the ID is unique. In our case, for example, if we say PRN number of the student and name, we can say these two together form the super key. PRN number of the student and name, these together form the super key. But if I remove this name, the PRN also identify each and every student uniquely. So this name becomes the extraneous attribute. Even if we remove it, the remaining attributes uniquely identify each entity. And these extraneous attributes, when we remove these extraneous attributes, it forms the minimal of super key. It forms the minimal of super key that we call candidate key. What we call it as a candidate key. So a candidate key of an entity set is a minimal of super key. So if we remove name from here, ID is the candidate key of the instructor. ID is the candidate key of the instructor. Now the next and very important is the primary key. It is possible that for a relation, for entity set, there may be multiple candidate keys. It is possible multiple candidate keys for that relation. So although several candidate keys may exist, one of the candidate key selected as the primary key. One of the candidate key selected as the primary key. And who decide this primary key? Who select this primary key? So primary key is the candidate key chosen by the database designer to uniquely identify each entity. So primary key is nothing but one of the candidate key which is selected by the database designer, database administrator, etc. Now, what are the properties of this primary key? The primary key should be chosen such that attributes are never or very rarely changed. Attributes are never or very rarely changed. So, ID, PRN number of the student. So, PRN never change. It remains as it is lifelong. Remember that. University PRN number, we can use or refer it anytime. It is never changed. So such attribute we choose as a primary key which never or very rarely change, and its value should be unique. Its value should be unique. So you can observe here the ID of each instructor is unique. The PRN number of each instructor is unique. So in this way, these three keys are defined. Again, I am repeating in simple the definition. A key is the set of attributes that sufficient to distinguish entities from each other. A super key is of an entity set is a set of one or more attributes whose values uniquely identify each entity in the entity set. Example is given here. ID and name is the super key of instructor, but a super key may contain some extraneous attributes. When we remove these extraneous attributes from the super key, it generates a minimal of super key. We call it as a candidate key. So for a particular relation, there may be multiple candidate keys, or a relation or an entity set may have multiple candidate keys, and one of the candidate key is chosen by the database designer as a primary key. Once this is chosen as a primary key, the properties of the primary major two properties of the primary key should be its attributes are never or very rarely changed, and its value should be unique. And its value should be unique. So how to identify this candidate key? A relation or an entity set may have multiple candidate keys. How to identify that multiple candidate keys? How to choose the primary key? That concept again we are going to see in the normalization. How to identify the candidate keys. So along with these three simple keys, there is another type of key, that is foreign key. So this definition we are going to see here, only definition. Actual examples while creating the tables, we are going to see in detail the foreign key concept. A relation, say R1, may include among its attributes. A relation, say R1, may include among its attributes the primary key of another relation R2. A relation R1 may include among its attributes the primary key of another relation R2. This attribute is called a foreign key from R1 referencing R2. So the example, simple example is given here. The instructor we consider as a R1. The instructor we consider as a R1 and this department as R2. So again I am repeating. A relation, say R1, means the instructor relation contains among its attributes the primary key of another relation. The primary key of another relation. So department name is the primary key of department relation. So instructor contains among its attributes the primary key of another relation. This is known as foreign key for instructor relation referencing to the department relation. This is known as foreign key of the instructor relation referencing the department relation. So in this case, R1 is called referencing relation. So this is called referencing relation. And R2 is called referenced relation. R2 is called referenced relation. So remember only the definition here, foreign key. Any relation R1, if it contains among its attributes the primary key of another relation R2, then this attribute is called foreign key for R1 referencing R2. Another example, student. So student, I write here SID as the ID of the student, name, department name, and credits. So the primary key of this relation is SID. Okay. Primary key of the relation is SID. But this department name, what is it? It is the primary key of department relation. It is the primary key of department relation. So it becomes the foreign key for students referencing department relation. And this is referential integrity constraint. This is known as referential integrity constraint, which is very important while we create the table. Means what? I am explaining in short here. For example, while we create the table, first we need to create department table. Okay. Name of the department such as CSE, then ETC. Suppose this, then make. These departments are there with their building and budget. Now, while the values are inserted into the instructor relation, the department name should reference from this department relation. Now, I insert my name DKJ. Okay. ID of my ID F408 DKJ. My department name is CSE. And then my salary. Okay. So here, this CSE, where it is reference? It is reference from this department relation. This CSE, from where it is reference? It is from department relation. Now suppose I enter another F409 with another faculty name I use here, suppose RBP. And I write here IT. Is it correct? With some salary. So it is not correct. Why? Because the IT department does not exist here. So I can't insert the value IT here for department name. Why? This department is referencing to this one. Why? Because this department name is referencing to this department only. So whatever the names of the departments here, that only I can insert here for the faculty. In the same way, that only I can insert for the student. That is known as referential integrity constraint. What is the constraint on this department name here? That department name should be there in the department relation. In the same way, suppose I insert the value of the student relation, student ID as 101, name of the student as XYZ, then I insert here fraud with credits 23. It is wrong, or it not allowed us to enter this department. Why? Because this department does not exist in the department relation. And that's why it depends upon the department name. Whatever the value I am inserting here, it depends upon the department name of department relation. That is known as foreign key constraint or referential integrity constraint. What we call it as a foreign key constraint or referential integrity constraint. Okay, so always remember this referential integrity constraint concept. Any number of. So another example I give here. Instructor entity set is there, student entity set is there, and advisor is a relation between that. So what are the attributes of the advisor? Primary key of student, primary key of instructor. So I use here SID as a student and IID as the instructor for it, primary key. So these are the primary keys of student and instructor, means these are the foreign keys for advisor, but these are the primary keys of another relation. So SID referencing student relation while IID referencing instructor relation. So every key or every attribute normally in a relationship set is a foreign key. Why? Because it is the primary key of another relation. Relationship set values or the attributes are always primary keys of another relation. Now, the keys for relationship set. We have seen keys for entity set. Instructor entity, what is the key? Student entity, super key, candidate key, primary key, we have seen. Now, the keys for relationship set, that concept we are going to see here with example. So, let R be a relationship set involving entity sets E1, E2 to En. There are n number of entity sets which are participate in the relationship set R. Let primary key EI denote the set of attributes that form the primary key of entity set EI. Means E1's primary key is primary key E1. E2's primary key is primary key E2. That notation is used here to identify the primary key. Now, if the relationship set R has no attributes, descriptive attributes associated with it, then the set of attributes primary key of E1, primary key of E2, union primary key of En all together describes an individual relationship set R. Now see with example, we consider the advisor relation between the student and the instructor. See again I am reading it. If the relationship set R has no associate descriptive attributes, its own attributes with it, then the set of attributes primary key of E1, primary key of E2, union of all these becomes that relationship set R. So how we describe the advisor relation? We describe the advisor relation as there are two entities that participate in that relation. Two entities participate in that relation, student entity and instructor entity. So both has primary key. We consider student SID as the primary key of student and IID as the primary key of instructor. So SID, and write at the first instructor, IID, comma, SID. How we define that relation? With the primary key, union of the primary key of all the entities that participate in that relation. See, again, this concept is very important because we are going to convert the ER schema, ER diagram into schema diagram. So, in that case, it is important. Next one. Annotation दिसत नाही का रे सगळ्यांना? If the relationship set R has attributes A1, A2 to AM as associated with it as descriptive attributes, then the set of attributes union of primary key of E1, primary key E2, primary key En, union all of its descriptive attributes. Again, I am going to consider the same example. I have suppose the advisor relation has its own attribute, that is date. So how we describe this advisor relation then? As the primary key of instructor primary key of instructor. How we define it? Primary key of instructor IID, comma, the primary key of student, comma, union of primary key of all the entities that participate and its own attribute. So suppose date is its descriptive attribute. That's the date on which that instructor becomes the advisor of that student. So in this way, we describe the advisor relation if it has its own descriptive attributes. In both the cases, the set of attributes primary key of E1, primary key of E2, primary key of En becomes the super key of that relation. So what is the super key of advisor relation? The super key of advisor relation is SID and IID. Both together form the super key of the advisor relation. Union of all the primary keys that of the entities that participate in the relation become the super key of that relation. Now the next one. What is the key of the, how to identify the primary key of the relation? Now we know what are the attributes of the relation, but what is the primary key of the relation? So the structure of the primary key of the relationship set depends on the mapping cardinality of the relation, whether it is one to one, one to many to many, or many to one. Depending upon that, the primary key is finalized. Consider the entity set, again with same example, instructor and student, and the relationship set advisor with attribute date. Now, if four cases are there, first case, if it is a many-to-many relation from instructor to advisor, again from to word is very important when it is one-to-one or one-to-many. Many-to-many, if it is a many-to-many relation from instructor to student. The primary key of the relationship set, if it is a many-to-many, from two word is important here. From instructor to student means one instructor associated with any number of students, one student associated with any number of instructors. So the primary key of advisor consists of the union of the primary key of instructor and student. Union of the primary key of instructor and student. So what is the primary key of advisor in many to many? If it is a many to many, then it is the union of the primary key of instructor and student. So here normally the primary key, it is underlined. So what is the primary key of advisor? Both of these becomes the primary key of advisor. Union of primary keys of instructor and student. Now the next case, one to many. Again, from two word is important. If it is one to many from instructor to student, means one instructor associated with any number of students, but one student associated with at most one instructor. So if it is one to many, then primary key of the advisor is simply the primary key of student. Means which side? Student, many side. Which is at many side? Student is at many side. So the primary key of student becomes the primary key of advisor. Primary key of students become the primary key of advisor. So the advisor relation IID, comma, SID, and the date is there. Okay, has its own descriptive attribute. So what is the primary key of this advisor relation now? If it is one to many, so many side becomes the primary key. So many side is the student. So I now underline only SID. Why? Because SID is its primary key. What is the primary key of advisor? So the primary key of advisor is SID. Okay. Now the next case. If it is many to one from instructor to student, means one instructor associated with one student, but one student associated with any number of instructors. If it is many to one from instructor to student, then the primary key of advisor is simply the primary key of instructor. Again, many side. Who is at many side? Instructor is at many sides. So the primary key of the advisor is the primary key of instructor. So what is the primary key here in this case? Advisor. I write here the attributes of advisor: IID, SID, and date. Among that, What is the primary key here? Many side. Who is at many side? The instructor is at many side. So the IID becomes the primary key of the advisor now. That is many to many. Sorry, many to one. So I write here the primary key of the advisor relation now in this case is IID. And the last case is one to one. One to one from instructor to student means one instructor associated with at most one student and one student associated with at most one instructor. Then the primary key of the advisor is either the primary key of student or the primary key of instructor. Any one we can consider as the primary key. Again, it depends upon the database designer. So what is the primary key in this case of the advisor? Primary key of the advisor in this case is either IID or primary key in this case is either SID. And that's why mapping cardinality is concept is very important when we design any ER model. When we design ER model, if we define the mapping cardinality in proper way, then it is very easy to identify the primary key of the relationship sets. Again, I am giving one example that if we consider the relation between the department and the instructor. Department and instructor. So it is always one to many. It is always one to many from department to instructor. One department, many instructors are there, but one instructor associated with at most one department. As a faculty, in our CSC department, there are 31 instructors. So one CSC department has 31 instructors. But one instructor, suppose myself, as an example, I am associated with only CSC department. So that is one to many. One example. So in this way, again, I am repeating, try to identify the different examples in our day-to-day life for understanding the concept of one to one, one to many to many, and many to one. Then it becomes easy for you to draw the ER model. These entity sets are there in our example of university database, classroom with attributes building room number, capacity with building and room number as the primary key, department with department name, building budget, department as the primary key, course with course ID, title, credits, course ID as the primary key, instructor, IID, name, salary. In the book only ID is given. I have added here IID so that we can distinguish between SID and IID. Then section with course ID, section ID, semester year. Here you can observe these four and all the four attributes is the primary key. Student with SID as a primary key, time slot. Then these are the some relationship set between these entity sets. Teachers is the relation between the instructor and the section. The particular section is teachers by this particular instructor. So the primary key or the attributes of teachers is IID, course ID, section ID, semester and year. All the attributes of section is the primary key. You can observe here. And that's why all these attributes are here in the relationship set teacher. Similarly, text is the relation between the student and the section. The student takes this course or enroll for this section. So again, SID is the primary key of student. So it is here along with these four attributes. Why? Because these four attributes is the primary key of the section. That's why all these are here. You can observe here section, all the four attributes is the primary key. So all these are here along with this grade. What is this grade? It is the descriptive attributes of text. So these advisor, SID, IID, both are there. Means it is a many to many. Student to instructor, it is many to many. Both become the primary key. Then instructor department, IID department name. Student department, SID department name. Course department, course ID department name. So these are the relationship sets between the different entity sets. And we decide the primary key depending upon whether it is one to one, one to many, many to one,